Hi, I'm Richard. In this video, I'm going to review HRV breathing in more detail. The pacer is set at 6 breaths per minute. If you inhale when the yellow guide travels uphill and exhale when it travels downhill, you'll be breathing at 6 breaths per minute. This person is breathing at about 6 breaths per minute right now. And the blue graph here represents respiration cycles and the red graph represents HRV cycles. And because of the variation in the time interval between each heartbeat, it creates these rhythmic acceleration and deceleration of the heartbeat. Later on, I will examine these interbeat intervals with Excel spreadsheet. During inhalation, heart rate increases to about 92 beats per minute. During exhalation, heart rate decreases to about 72 beats per minute, and the cycle repeats. The difference between maximum heart rate and minimum heart rate per respiration cycle is calculated and shown here from about 21.3 to 19.8 beats. One of the HRV training objective is to increase the difference between the HR maximum and HR minimum. In What is Heart Rate Variability video, I had a detailed discussion of interbeat intervals. Let's briefly review here. By definition, HRV is the variation in the time interval between heartbeats because of the R2R time differences in EKG. And because of the variation in interbeat intervals, breathing at a certain rate creates the HRV and the respiration cycles resonate with each other, as you can see here. When the peak heart rate and the end of inhalation occur at the same point as they are here, it is said to be at the resonance frequency of that individual. This is a 30-second span of HRV breathing exercise, and I decomposed each individual heartbeat that had occurred during this 30-second span. The numbers at the bottom represent interbeat intervals for every heartbeat that had occurred during the span. The numbers at the top represent corresponding heart rate for all the heartbeats or interbeat intervals shown at the bottom. The first heartbeat was 0.7787 seconds and the corresponding heart rate was 77.05 BPM. If the IBIs were constant at 0.7787 seconds, the BPM would also have been constant at 77.05. However, the IBIs are not constant, and the BPM is different for every corresponding heartbeat. For example, the second IBI is 0.7188 and the BPM is 83.47. When the IBIs were converted into an Excel bar graph, as you can see here, acceleration and deceleration of heartbeats are rather prominent as the heart rate speeds up and slows down. Let's talk about resonance frequency a little bit more because it will be the main focus of HRV breathing exercise. Resonance frequency is when the peak heart rate and the end of inhalation occur at the same point. Peak heart rate for each respiration cycle are here, here, and here. And that's where inhalation transitions into exhalation. Therefore, this person is breathing at his or her resonance frequency, which is about 6 breaths per minute. Professor Paul Leha of Rutgers University has shown that the daily practice of resonance frequency training increases the total amount of HRV, increases baroreflex gain, and improves pulmonary functions. A baroreflex is a reflex mediated by blood pressure sensors called baroreceptors in the aorta and carotid artery that help modulate blood pressure fluctuations. That's another topic of presentation. For the purpose of this presentation, however, since we know that the resonance frequency breathing increases HRV, if you could produce maximal increase in heart rate during inhalation and maximal decreases during exhalation like this person is doing, then you would be breathing at the resonance frequency produced by your baroreflex system. Now the question is, how would you know if you were producing the maximal increases and maximal decreases in heart rate during inhalation and exhalation? My recommendation is to find a BCI certified biofeedback trainer in your area and have the trainer determine your resonance frequency respiration rate. FYI, Professor Leah and his colleagues found that for most people, the resonance frequency respiration rate is between 4.5 and 7 breaths per minute, and the average resonance frequency respiration rate is 6 BPM. For educational purposes, I have uploaded HRV breathing exercise videos with different respiration rates in this channel. Try for yourself and see what works best for you. I'm Richard, and thank you for watching this video.